Okay, so good morning, everyone, or bon dia, hola, hao, depending where you are in the world. Thank you very much to all of you for joining us today, particularly thanks to the speakers who are making this workshop possible. And welcome to the 8th East-West workshop on industrial archaeology. For those of you who don't know me already, my name is Juan Manuel Cano Sanchez. I am from Spain, even though I have been working in China at the University of Science and Technology, Beijing, since 2018. And I am also a council member of the Association for Industrial Archaeology in the UK, which are the two institutions, USTB and AIA, that are supporting this series of workshops. So today, as you already know, the main theme we are going to be discussing is the archaeology and heritage of the metallurgical sector. And we are going to do this since or from ancient times to contemporary history. So that means that in this edition of the workshop, we are again understanding industrial archaeology and heritage in the longest possible sense, not limited to the modern industrial period or modern industrialization, but also paying attention to industry before the Industrial Revolution. Besides, and after our latest workshop, the 7th edition in November last year, that was more focused on architecture. Today we are going to be again a little bit more archaeological. So we are today coming back to a more archaeological perspective. To do so, we have two archaeologists from China and Britain, but we also have an architect from Spain who will also bring us into other approaches, architectural history and industrial heritage, particularly with the support of digital technologies. So what we have prepared for you today, first we will go to China, ancient China, to discuss the mining and metallurgy of the northern frontier area from an archaeometallurgical perspective, from the perspective of archaeological science. But don't panic that literacy in chemistry is not required to follow this first lecture. From there, we are going to Wales in the UK to continue learning what archaeology can tell us about modern industrial sites through the most characteristic of popular method of archaeology, the excavation. This is a topic that we have explored before in the second workshop with Otis Gilbert, and also in the latest workshop with Ian Miller. And today we will further develop these discussions with a new piece of archaeological excavation from off an industrial site, this time in Copperopolis, that is how Swansea in Wales was once known. And finally, we will go virtually to Spain, or perhaps some of you actually physically, since Bill is taking some of you to Catalonia on Monday, if I am not mistaken. And there we are going to visit virtually, which is for me, one of the most impressive and interesting industrial archaeological sites in Mediterranean Europe. We are going to visit the industrial side of Peñarroya Pueblo Nuevo with an introduction of a virtual tour that is being developed by Maria Isabel Payer in recent years. So as some of you already know, first we focus on these three presentations, and finally we will have some time for discussion and questions and answers. So until that time, please keep your microphones and cameras off so we can focus on the presentations. At the end, as I said, everybody is welcome to use microphones and cameras to contribute to the discussion. Otherwise, you can also use the chat facility anytime to share your questions, comments, suggestions, ideas, and so on. So we start in China, as I said, with Dr. Chen Yuan Li, who is going to present the paper, The Evolution of Mining and Metallurgical Production Technologies in the Northern Frontier regions of China during the Qin and Han dynasties, a perspective from archaeometallurgy. So Dr. Chen Yuan Li, he is a lecturer at the Institute for Cultural Heritage and the History of Science and Technology, which means that we are workmates and actually friends. Before being a lecturer here, he got his PhD in the history of science and technology, also in this university, the University of Science and Technology, Beijing. Before that, he was studying in Sweden, where he got a master's degree in materials processing technology from the Royal Institute of Technology in Sweden, as I said. And also he has a bachelor's degree in physics from the Jilin University in China. So Chen Yuan's expertise is archaeometallurgy, and in a broad sense, he works with the identification and conservation of ancient Chinese metallic artifacts of almost every kind, almost every metal or alloy, even though his specialty or he's particularly interested in these frontier regions of North China and how mining and metallurgical production were developed there under the influence under different social structures. So this is the topic he's going to talk to us today, and I will not take more time from your presentation, Chen Yuan. So please, the floor is yours.
Okay, thank you, Professor Huan, and I will share the screen. So, okay. First, I want to thank Professor Huan to give me this opportunity to share our research in this workshop. As I'm a tour to the industrial archaeologists, and what we do, the research is kind of in a very narrow field. So I just want to give a brief introduction on our research. If any friends the interest in our research, please make your questions and we will discuss about it. And I will give my I will give my presentation in 4 parts. And first, I want to give some background introductions in this research, and also I will give some archaeological research results to share with the audience. And finally, I will give you the case we are working on to understand how the most frontiers of high density about. So, okay, I think I will do the introductions from the period we are focused on. It's the Qing and Han period. Basically, in the history research, we define this from the 221 BC to 220 AD. It's about 441 years. And it's a very important period of Chinese because it's the first centralized imperial dynasties. And the Qing is a very short-lived dynasties. It's only less the Qin Shi Huang, the first emperor, and because of the harsh governance, it led to the social unrest and collapse very quickly. But the Han Dynasty, they refined the Qing system, but they reused the whole systems, but they promoting Confucianism instead of the legalist principles. So let's make the social more stable, and let's make I think is maybe the most important dynasties in the history of China. For the frontier studies, I think the Emperor Wu, as we call it, Han Wudi, is quite important because they have expansion the whole realm of the empire. So I will do we will do the research mainly focus after the Han Wudi period. I will show you why, because when the formal study of the histories, we mainly focus on the military perspective on the north frontiers, because we have when we focus on the Han Dynasty histories, there's always three periods to analyze the frontiers. First is the early period when the Han Dynasty just founded. They will stay in the defense situation with their northern neighbors, with which we call the Xiongnu, also we call Hun Han. So because the Han and the Hun Han and the Han Han is kind of similar, so we use Xiongnu in our presentation to make it different. So, and in the second period, the Han Wudi and the Emperor Wu, they have they have a very strong military force, and they make the expansion of the Han Dynasty. And after him, the Han, the frontier of the Han is kind of solid. So it's in a consolidation period, and that's what we studied in our research. I will give you a map about the difference before the Han Wudi and after the Han Wudi's expansion. You will see the exchange and expansion of the frontiers is in all the directions, both on the north and the west, and also the east. But the most important part is in the north part, and the most primary rival, I think, is the Xiongnu as the enemies of the Han Dynasty. But actually, in the Qing and the Han Dynasty, in this period, we not only bothered with the Xiongnu, we also have other tribes like the Donghu, and we believe there's also a nomadic civilized just like Xiongnu, and also a very ancient people they call the Qiangren, is to the best of the Han and Qing dynasty. And in some of the traditional the research, we only to see the military conflicts with the two different cultures. But in fact, if you have met the terracotta warriors, you will find that there are actually a lot of different kind of people in Qing dynasty, and the Qiangren, and also the nomadic people in the west have joined the Qing dynasty. So the whole the whole conflict in the history is not so so simple. It's also a mixture with all the races and all peoples in the northern frontiers. And the second, we want to talk about our research field. Our groups, we focus on the archaeometallurgists, but I think after the 2015, when we with our groups with cooperation with our colleagues in Germans, like the Professor Poniska and Hauptmann, we began to change our we began to focus on more about the mining archaeological part. I think this part is in our works is more have more relations with the industrial archaeologists. We from that times we not only just focus on the unearthed artifacts and other like slags and furnace fragments. We pay more attention on the mining activists, and we pay more attention on the social impacts of all the activities and the pay. I think it's to make our workers could be more more related to the industrial archaeology and the economy archaeologists. As also in these years, we are trying to make our works more to cross the disciplines. And for more specific in our research, we focus more on the operation chain. This is kind of very famous series. When we deal with the I think deal with the metallurgical archaeologists, but in our case, we used to only focus on the smelting sites and the metal craft. But when we have the studies more and more in more and more, and as it become very complicated, we cannot solve a lot of problems. Then we try to move our attention on both the mining and the perspective of the mineral deficit, and we find them another field experts just like the geochemistries and anthropologists, and they help us to do the work. Now we try to make our research in the whole perspective of the operation chain, as make our studies I think is more complicated, and this help us to learn a lot more compared to the foremost. And in fact, in Qing and Han dynasties, we already know a lot of details about the technologies, since we already unearthed a lot of the tools, and we have the records of the literature's records on the bamboo slips, and we know how the people doing how people do on the minings, just like how these portings, and we have the size of the excavations, and we also know the details about how the metallurgy and the metal crafts produced, and we have the site about the beneficiations and refining of the minings, and we have the smelting size in this in Han dynasties, and so very large, and in Henan province. And but we still don't have is we cannot understand how the people, the miners and the artisans, how they operation, how they organize and in the size, because we only know the government's the tax of the governments, but we don't know how the peoples and the laborers do. And we only have some very little text about the rise of the minings, but and the legal terms of the minings and productions, but we don't know how the real works, and how the networks and the communications of the resource are going in the networks. So there's still a lot of part of the of our research is unknown in this period, and we're trying to deal with it, and we're trying to make the understand more and more clear. So I want to give a very brief background of the metallurgy patterns in China. Since I used to working on the pre-Qing period of China. In the Bronze Age of China, there's mainly four bronze technology regions in China, and you can see in the north frontiers we got two different regions of the pre-Qin period. But in the Qin and the Han dynasties, we found that the technology in the north frontiers of the Bronze is almost the same. I think it's because of the standardized in Qin dynasty, and also in the Han Wudi, we were mentioned about, and they have the military expansions, and he make the economic reforms, and they let all the copper resource scattered in some centralized urban city. So the result was the mixture together, make the technology become unified in this period. But if we see the iron and the steel production technology is another stories, because in the Han Dynasty, I think the most important invention is the casting iron productions, which in our point of view, that's I think the cast iron technologies make the Han Dynasty one of the most powerful emperors in the region. So the cast iron technology has kind of special things, because they have the different package of the technologies, and they need a huge, very tall, 5 to 7 meters furnace to obtain the high temperatures, and they have very high efficient blows, and the fuel supplies for a very rather high temperatures is around 1500 degrees, which is very hard to get in that period. And also the Han Dynasty, in the Han Dynasty governments, they have established 49 iron officials. They have the specific bureau to control this kind of systems. And this term, in this technology systems, we have some unique techniques like the ductile casting irons to make the very brittle cast iron, and they become ductile. And we also use the stir fry technology, which is called 炒钢, and forging. And forging like a 百炼钢 the technology to decarbonize the casting iron to make the brittle cast iron to reform, and to produce the tools and other agricultural tools and weapons like that. It's very high efficient compared with another technical technologies, which is which I think is more familiar with the Western people, is the bloomery technology. But not we Han Dynasty people. When the Han Dynasty, the artisans of China, we also use the bloomery technology. So we also have the daggers like the one unearthed from Shanxi. And we also find the bloomery furnace in Henan and other part of the China in Qin and the Han Dynasty. We use the technology, but only use for a very small scale, and only use for some very high quality steel making. That is the huge difference from the Han Dynasty and the other part of the world. And then I think, oh, sorry, and then we try to we try to mix our understanding on the metallurgies and other and the other part of the our archaeometallurgy our resolve to the traditional archaeology. In China, the traditional archaeology is based on the typology of the potteries. There's because especially in the Han Dynasty and the Qin Dynasty, the population is very high. So the unearthed potteries is have the enormous number of them. So we because we are not a specialist the typologies. So we in our research we use the AI as our assistance to collect the data, and we already know the Han Dynasty in the Central Plains have the different pottery the typology characters with the Xiongnu and other nomadic cultures. So we use the AI technologies as assistants to collect all the pictures of the potteries, and we label the pictures, and we use the data to make the to use the data and to label the images with Python. Our app is called the Label Me, and we use the NLP technologies to train the machine to help us to rescale all the typology research, and will help us to link the typology result to our archaeometallurgy data. And as in China, the other important part of the archaeology is the artifactual assemblage. We also use the kind of AI techniques to regale the to collect the data and to make the cluster analyze for the for our data, because there's a lot of the potteries, and for the understanding of nowadays, we cannot in a lot of the tombs the potteries seems very similar to each other, especially in the core center in our the core center of the Han Dynasty and Qin Dynasty. But in the frontiers, when we compare the domestic potteries with the Han Dynasty potteries, there will be much more difference. So we used the big data to make our metallurgical data to compare with the pottery data and help us to gain more reliable results. And to make sure that our work is as reliable, we also use visualize the decision make to supervise this kind of machine learning process. We use the GradCam technology and the Guide GradCam technology to make sure we focus on the right part of the pictures, and to make the right decision, and to understand the typology result very well. And after this, we can get the result of the traditional archaeologists more. I think it will make it more efficiency, and which make our results more objective, since we could use the mathematic models to evaluate our data and our result. And sometimes since the AI technology has developed very quickly, it helps us to have a more deep insights, and to find out some conclusion that even for our human cannot find. So I think the AI system, the AI technology is kind of very helpful in our research in the future days. So we also try to introduce some other series in our research, such as when I was still in my PhD programs, Professor Simon Stoddard has come here, and the first time I just reached the Frontier series. He gave us the lectures about 7 days, and we know the Turner's American Frontiers, the mode, and the Koptov's African frontier mode, and also we focus on the cosmos nomadic interactions mode. But I think our research is kind of different from from these theorems, because here also Professor Simon he recommend us the G's and big data should be to involved in our research, but we didn't find a very proper way to investigate to our frontiers problem. But in the recent years, I think another frontier theorems was the discussion in China. It's called the world system series. We know it's kind of classical. The Wallenstein's world system series about the periphery and the semi-periphery and the core three part of the whole system. It helped us to understand how it works and how the different parts of the regions goes. And we also find the Professor Andrew Gander Frank's Asian world system series. It's kind of different from the classical one, because the classical one is focused on the 500 years system. Is from the 16th centuries, and the Asian world system is about 5,000 years. It's kind of that China has been the center of this systems, but in fact, it's both the theorems is emphasize some kind of imperial conquer series. But in China, we cultures believes more harmony cultures. We will try to gain a coexist pattern in our culture. So this kind of series is not so popular in China, but I think we will absorb the basic mode, and I think there's some very good ideas of this series to our studies. And here's our cases, and in fact we already got lots of data, like we have known how the iron and the copper's artifact, how it's were make, and we found out the mining zone, and we found the smelting sites for in this period. We also gathered a lot of the sites in the north frontiers. We have about hundreds of the sites of studies, and we got thousands of the data of all the artifacts. But in fact, in the Han Dynasty, the scenarios are kind of complicated. We have to deal with the mixture of the result, the isotopic data, and also other content data. It's kind of mixed together. So we have induced some other math models is by Professor Liu Siran and Dr. Sun Zhenfei, and we try to use the mathematic tools to help us to find out the actual the resource come from. Now we find that in the central plains and in the Han dynasties, we found 5 different source of the of the lead as topics is very useful for our research in the future. And also we use the series we mentioned about to just make the our north frontiers in three different zones. The first is the core area. We call this the basic economic zones. This part is central of the Han Dynasty, is including the Wei River Basin and the Yellow River Basin. And we set the semi periphery part as the Yanliao region is in the north in the northeast of China, and the central south of in the Mongolian part is we set this part the semi-periphery region, and the most the distance one from our frontiers is Mediterranean Gazon type Heshi corridor and symbol type regions is in the northwestern Korea. We could see it in the map. So here is our core, and this part and this part is our semi preference, and we can see the western part and the green part of this our preference part. And for the data and all the results we've got, we think maybe we could deal with some problem like construction, the evidence chains of the technology dissemination pathways on the material provenance and decoding the technology genes, and also tracing the technology deductions, how they developments, and also in more complicated problems, we think our understanding could help us to solve the network in this region of Han Dynasty, since we could make the spatial temporal modeling of the resource based on our GIS data, and also other resource data of all artifacts. And finally, I think maybe we could, if we're lucky, we got some understanding. Nicely, we could make sure that we could try to deal with some civilization work, like why the different part of the nobles they choose a different kind of different artifacts to to symbolic their powers. What kind of the logic behind this different choice and the different technology of this culture. I think this if we done our work nicely, we could have the opportunity to touch this kind of a field. That's our work, and thank you for the opportunity, and we're looking forward to the cooperation. Thank you.
Okay, thank you very much, Chen Yuan. That is indeed a very impressive research, both considering the level of the theoretical level and also the methodological implications. It's like a very advanced theory methodology combined together. So your results are actually fantastic. And it has been an amazing general introduction to the topic. I think it was impossible to say more in this limited time, but you really gave us plenty of ideas, information, and inspiration. So thank you very much. Very good job.
Thank you, sir.
So now we travel to Swansea and several centuries into the future, from ancient China to contemporary or modern Britain. where we are going to rediscover Copperopolis, particularly the half-of-plate rolling mill in Swansea, which is going to be explained to us by Dr. Rhys Morgan, who has a PhD from the University of Southampton that he got, I think, in 2021. And since then, he has been working full-time in commercial archaeology, currently as a project officer for Black Mountains Archaeology in South Wales. So in all this year working in the field, Dr. Morgan has excavated several industrial sites in South Wales, including sites within the Blind Able World Heritage Sites that, as everybody knows, is a place of outstanding universal value regarding iron production and coal extraction. So Rhys is obviously interested in these topics, the iron working and coal mining. Besides, he has published about copper working and also industrial transport. Today, precisely, he's going to talk about one of his latest publications about the copper industry. More specifically, he's going to share with us the results of an excavation from 2021 that was developed in the half-of-plate rolling mill of Swansea, and that involved the participation of the community. So I am very much curious about this experience, about this case. So Rhys, please start your presentation.
Yeah. Can everyone see the presentation?
Yes.
Yeah. Okay. So, hello everyone. This talk details a community excavation that we, as in Black Mountains Archaeology, undertook back in 2021 at the former site of the so-called Hafod Plate Rolling Mill in Swansea, situated near the South Wales coast, which once belonged to the Hafod Morfa Copper Works. The talk will mostly cover the information set out in our Industrial Archaeology review article, but we'll also incorporate some additional stuff that wasn't available to us at the time that the article was written. It's important to mention the background to the project and its various stakeholders. So the archaeological excavation formed part of a wider regeneration and preservation project in Swansea, which covers the Hafod Morfa Copper Works. One of the more notable elements of the regeneration project was the transformation of part of the copper works into a working distillery. As part of the project, several archaeological investigations were commissioned, and we've been working across the Hafod Morfa site for, I think, about 7, maybe 8 years now. This talk, therefore, only covers a small element of the wider archaeological program. In other words, there's still a ton of material and there still needs publishing, which stretches way beyond the Hafod Plate Rolling Mill. The mill, after all, comprised only an element of the wider Hafod Morfa site. As you can see here, the regeneration project was commissioned by Swansea Council and was funded by the National Lottery Heritage Fund. The project has also won and has been shortlisted for a wide variety of national awards, which are summarized on the right. Before delving into the archaeological investigation that we conducted at the rolling mill, it's worth briefly outlining the history of the copper works to which the mill belonged, as well as the general history of copper working in Swansea. For those of you who are perhaps unfamiliar with the geography of the UK, Swansea is situated in Wales, which forms sort of the southwest side of the island. So Wales is shown here, and the so-called Lower Swansea Valley, within which Swansea is situated, is shown in the black box. Industrial scale copperworking began in Swansea in 1717 and really exploded throughout the remainder of the 18th century and the following 19th century. Copperworks were established all over the Lower Swansea Valley and were mainly concentrated along the banks of the River Tawe, which flows approximately north-south through the centre of Swansea. By the start of the 19th century, the Swansea region may have produced around 90% of the world's copper. This is an almost unbelievable figure, and it really highlights the important role that Wales played in the Industrial Revolution. The area of Swansea is colloquially known as Copperopolis, although Copperopolis witnessed serious industrial decline throughout the 20th century. Copper working continued until 1980 before basically halting altogether. So it's very much a kind of post-industrial landscape now. As I've already mentioned, our archaeological excavations covered the Hafod and Morfa copper works. These were later amalgamated, which is why the site is today known as the Hafod Morfa copper works. And this illustration nicely encapsulates what the lower Swansea Valley, or Copperopolis, looked like during its industrial heyday. The illustration is from a French magazine known as Le Tour du Monde, which reported on like expedition or travel destinations during the 19th century. And it turns out that Swansea was one of these destinations. The pollution across Swansea at this time would have been pretty unbearable, as hundreds of furnaces and chimneys basically choked the landscape. As can be seen in this illustration, the River Tawe, which penetrates the landscape, served as a vital transport corridor which connected all the individual copper works along with other connected sites such as collieries, quarries, ironworks, and so on. As you could probably appreciate, copper working wasn't just about copper. It brought in a whole host of other ancillary industries which fed Swansea's copper works with, for example, fuels, fluxes, bricks, railways, and a multitude of other equipments and material. It's also important to appreciate that copper wasn't just copper. It was manufactured into a multitude of different forms, each with different functions. For the purposes of this talk, which focuses on a historic rolling mill, the most important forms of copper were plates and sheets, which were formed by rolling pre-formed slabs of copper into flat and relatively thin sections, ready to be sold to a range of for a range of different uses. Some of these uses will be touched on later. The earliest of the Hafod and Morfa copper works was the Hafod site, founded between 1808 and 1809. The copper works was positioned near a bend in the River Tawe. As demonstrated on this 1777 plan of the river, the site, which is marked in red, was at this time void of industrial features and was positioned immediately opposite the so-called White Rock copper works. Throughout the 19th century, the Hafod copper works grew exponentially, and by the late century, it may have been the largest copper working site in the world. Large-scale smelting was occurring across the whole site, as well as casting and rolling. The Morfa copper works came later, which was positioned immediately north of the Hafod site. The Morfa copper works was established in 1828. Initially, it seems that no smelting was going on. Instead, the works were dedicated solely to the rolling of copper bars into plates. The rolling of copper into bars and plates. Rolling operations were centered on the Morfa rolling mill, which is shown on an 1842 map of the area on the left, which is circled in red. When built, again, this may have been the largest rolling mill in the world. By the 1830s, smelting operations began at the Morfa site, and throughout the 19th century, additional plant and mill buildings were continually added to the works, as indicated by the 1894 plan on the right. Starting in around 2018, we have undertaken large-scale archaeological excavations of the Morfa copper works, and here's a small glimpse of the kinds of features that we uncovered. On the left is the remains of a reverberatory furnace, which was positioned on the interior of a large cast house. The reverberatory furnace was one of the key innovations of the Industrial Revolution in Britain, as it allowed metals and fuel to be heated separately in a way that kind of minimized cross-contamination. Like most other industries in the 19th century, both the Havard and Morvern copper works relied heavily on the reverberatory furnace in both smelting and like reheating operations. On the right is what I would describe as a complicated tangle of archaeological features, originally situated within the Morvern rolling mill, which mostly comprises flues, floors, and furnaces. So as we can see, the site of the Havard and Morvern copper works is a rich archaeological resource. As is demonstrated on this plan, the Havard and Morvern sites were neighbours and were separated by a long boundary wall. So that's this here. But in 1924, an amalgamation agreement was made, which led to the Havard and Morvern sites becoming a single unified site. This plan demonstrates the main kind of plant and mill buildings attached to the Havard and Morvern sites as they existed in the late 19th century, so before the amalgamation agreement. Circled in red is an area that would later be inhabited by the Havard plate rolling mill, which forms the focus of the present talk. As we can see, the mill is positioned on the south end of the Havard site and is occupied at this time by two earlier rolling mills, known as the numbers 1 and 2 rolling mills, as well as an engine house and a hammer house. The Havard plate rolling mill was built in 1910, just over a decade before the amalgamation of the Havard and Morvern sites. As we can see from this plan, the new rolling mill, outlined in black and kind of circled in red, was huge. In total, it measured approximately 111 meters in length. To make room for the building, the numbers 1 and 2 rolling mills were demolished. To provide power to the new mill, the so-called Musgrave engine house was built, which housed a Musgrave uniflow steam engine. This engine represented the pinnacle of steam technology during the early 20th century and was extremely efficient. I've been told that by somebody who's seen one in operation that it wasted so little energy through noise and vibration that you barely notice it was even on. So the photograph on the left, dating to roughly the mid 20th century, captured the Musgrave uniflow engine at the Havard site. In uniflow engines, steam is admitted at the ends of the cylinder and is exhausted in the center. Because of this setup, a constant temperature gradient is ensured along the cylinder, where the temperature at each end remains high and the temperature in the center remains relatively low. This then minimizes heat losses and condensation. In other words, the best possible use of the heat energy provided by the steam is ensured, which maximizes the thermal efficiency of the entire engine. Now, as somebody who isn't an engineer, that's about the limit of my knowledge on uniflow engines. Here are aerial photographs of the Havard Morvern copper works, with a Havard plate rolling mill circled in red. Both photos also provide an impression, which is almost unimaginable now, of the scale of industrial activity that once defined the area. So for the remainder of the talk, I'm going to focus on our archaeological excavations at the former site of the Havard plate rolling mill, which, as I've said, was undertaken in 2021. The excavations, as again I've already mentioned, form part of a community project. And as a result, we were helped by local volunteers and also students who were all really enthusiastic about rediscovering the history of their hometown, or in other cases, just gaining more hands-on experience in the archaeological process. Our archaeological investigations involve the excavation of 6 trenches, which are shown here. The trenches were concentrated towards the western and southern sides of the rolling mill's footprint. prior to the start of the excavation, the survival of the archaeological resource or the archaeological remains within the area wasn't known. The northern end of the rolling mill wasn't excavated by us in 2021, but as of last year, we've been undertaking investigations there in an area surrounding the Musgrave engine house, which I'll touch on soon. And each trench was recorded photogrammetrically, meaning that the archaeological remains uncovered within them were preserved as 3D, digital 3D models. And here are some orthomosaics or photogrammetric stills of the 3D models. The archaeological remains recorded within the trenches almost wholly related to the operations of the 1910 rolling mill. As I've previously mentioned, the site was, before 1910, occupied by the numbers 1 and 2 rolling mills of the 19th century. But archaeological remains related to these earlier mills were obscured by later activity and were not detailed in our Industrial Archaeology review article. We didn't excavate deep enough, basically. In summary, our excavations revealed a broad sequence of operations that once defined the interior of the 1910 rolling mill. The sequence of operations was linear, beginning in the north and ending in the south. In broad terms, the operations involved taking thick copper slabs, which were stored at the north end of the mill, and rolling them into thin plates and perhaps to a lesser extent, sheets, which are slightly thinner. These were then finished at the south end. Of course, the process was a bit more complicated than this and involved other intermediary or complementary procedures. Documentary evidence indicates that during the early 20th century, the rolling mill produced square and rectangular shaped plates, which could be applied to a range of different settings. For example, the plates were used to construct like structural brackets for steamships or boilers for locomotives. And they were also incorporated into things like singeing machines, in which like textiles are heat treated. So the northernmost operations that we uncovered related to the rope drive and rolls, shown here on the right in these photographs. Both survive as freestanding features, so these weren't excavated. And they're situated just beyond the northern edge of our excavation area. The rope drive was attached to and powered by the Musgrave Uniflow engine and fed into the rolls. A variety of roll types were positioned along the mill's interior, which reflected the variety of thicknesses the copper was rolled to before achieving its finished kind of plate form. In general, the rolls situated to the north were narrower, whilst those to the south were wider and therefore closer in form to the finished plates. And here's a photograph from around the early 20th century, which illustrates the rolling process. Rolling basically involved passing sections of copper between pairs of rolls, which rotated in opposite directions. Through repeatedly passing the copper through thinner and thinner rolls, where the rolls kind of got closer and closer together, the copper would continually decrease in thickness before reaching the desired form. Situated on the west side of the rolls were annealing furnaces, the remains of which are shown in the upper photograph, upper left. Both before and after being fed through the rolls, sections of copper were fed into the annealing furnaces to make them more malleable and therefore more amenable to rolling, like softer. On the south edge of the annealing furnace was a pickling pool. Only the edge of the pool was seen during excavations, and a large cast iron pipe was seen extending into the pool, as demonstrated by the lower photograph. Pickling involved submerging the copper so that surface oxides which accumulated during annealing or heating could be removed. These oxides were known as scale. The pickling solution, which was held in the pool and supplied via the cast iron pipe, probably comprised some kind of sulfuric acid solution. At the south end of the excavation, we uncovered features associated with finishing. In other words, these processes aim to bring the copper plates to a finished or kind of saleable form, ready to be sold. Firstly, we found the foundations of the shears, which was used to cut larger sections of rolled copper into individual plates. The shears were also used to kind of trim the edges of the plates and basically provide them with a kind of neat finish. Shears of this kind typically were of the kind of guillotine or scissor crocodile form. Unfortunately, the shears themselves had long been demolished by the time we excavated the sites. So that the plates weren't warped under the pressure of the shears, they were probably cut in a cold rather than hot state. We assume that the quenching bosch, part of which is shown in the lower photograph, was used to cool the plates down via submersion before being cut to finished form. As we can see here, both the shears and quenching bosch were composed of I suppose, a Portland cement type concrete, which wasn't available in 1910. Both therefore date to a later phase of renovation, which likely occurred after World War II. It's 1945. These renovation works were likely associated with further increasing the efficiency of the mill's operations. And here is a mid-20th century photograph of a quenching bosch. As you can see, it's basically a sunken, water-filled tank. At the west end of the mill, situated in an annex that was set apart from the main sequence of rolling operations, we recorded the remains of a so-called hot well, which was connected via a large cast iron pipe to the Musgrave engine and its boilers. As I've already said, I'm not an engineer, so there's only so much I can say about the intricacies of the hot well in the steam engine. This section of our article was covered by my co-author Tom, who is an engineer. Basically, the hot well stored water at a high temperature so that it could be pumped into the boilers or back into the boilers at a temperature sufficient to avoid excess wasted energy. Again, the hot well was composed of a kind of mid-20th century concrete and therefore belonged to the post-war renovation phases of the mill. And I thought it'd be a good idea to close this talk by briefly summarizing those excavations in and around the rolling mill that are still ongoing. At the north end, within the vicinity of the Musgrave engine house, which we just about see here, the whole area was stripped and recorded. These excavation works have been undertaken by another of my co-authors, Libby, and here's an aerial photograph demonstrating what's been uncovered. As we can see, the archaeology is very, very complicated and is yet to be fully interpreted. But quite excitingly, Libby has probably uncovered structural features attached to both the 1910 Havre plate rolling mill and the older 19th century numbers 1 and 2 rolling mills. Hopefully with this information, we can begin to establish the degrees of continuity that existed between the 19th and 20th century rolling operations. Thank you. Thank
you very much. Very interesting presentation too. Very informative of how much we can learn about modern industrial sites from archaeology. Not only because the archaeological excavation can reveal aspects from the past that were not documented, that we could not know otherwise. But also, I like it from your presentation how you combine this analysis of the material remains with the sources, with the visual sources of information, those all photographs and plans. I remember the words of Professor Madeline Palmer when she says that in the archaeological records on how we find the bones, the skeleton of the industrial past, and the visual sources help us to bring the flesh back to those bones, and so we can have a broader picture. I think your presentation has been indeed a very good example of this. So congratulations, a very very good job. As I have a post in the chat facility, your article is now open access. So all of you that have just listened to Ree's presentation, if you want to know more, you just need to click on the link and you can read the whole thing from Industrial Archaeology Review. So thank you. Thank you very much, Rees. So finally, we move to Spain, where we are going to have a different presentation. It's going to be a video presentation, something like what Gordon Davis shared several editions ago. Now we are going to discover, or we are going to immerse ourselves in metallurgy as industrial and urban development in Peñarroya, Pueblo Nuevo, Spain. Immersive video presentation that has been prepared by Maria Isabel Paller Ibáñez, who graduated in architecture in 2004 from the University of Seville in southern Spain, and where she is currently working for her PhD too. So Maria Isabel is the director of the virtual tour Cerco Industrial, that is the industrial complex of Peñarroya, Pueblo Nuevo, which is a project developed in the framework of the UNESCO Chair Creative Research and Education in Heritage Assessment and Regeneration, which happens to be the first UNESCO chair that is specialized in contemporary heritage. Maria Isabel is responsible, or was responsible, for the technical documentation for the declaration of this industrial archaeological site as an asset of cultural interest, in Spanish, bien de interés cultural, which is the maximum level of protection in Spain. And she has led several projects related to the preservation, restoration, and reutilization of several buildings and spaces, industrial buildings and spaces in Peñarroya, Pueblo Nuevo. Beyond or besides this professional experience, Paller is also an active researcher, and she has plenty of publications in industrial heritage. I would like just to highlight one of them, a book that she co-authored with Francisco Aute, about this place that she's going to present today. The name of the book is published in Spanish in 2005, but the name of the book is The Industrial Complex of Peñarroya, Pueblo Nuevo, Stone by Stone, by far the most complete presentation of this amazing industrial archaeological site that we are going to see today. So Bill, please, would you mind to share the video?
Okay, let me get that going.
Mm-hmm.
Metallurgy as an industrial and urban development of Penarroya Pueblo Nuevo. The current reality of the Guadiaro Valley is determined by its unique geology, with the geological and climatic conditions from 311 million years ago being the direct origin of the onset of mining and industrialization, and the later emergence of Pueblo Nuevo del Terrible. The area under study is located in the upper valley of the Guadiaro River, which occupies the northwestern half of the province of Córdoba and includes the towns of Belmez, Los Blasquez, Espil, Fuente Obajuna, La Granjuela, Abejo, Penarroya Pueblo Nuevo, Valsequillo, Villa Harta, Villanueva del Rey, and Villaviciosa de Córdoba. The geographical space occupied by these towns lies entirely within the Sierra Morena and features a combination of long valleys and vast mountain ranges. The beginnings of metallurgy in the region, from prehistory to the Roman period. Over the years, evidence of prehistoric settlements has been found throughout the Guadiaro region. Some of these have been documented, while others are known through the discovery of various objects from those periods, such as arrowheads or bifaces, more or less elaborately crafted depending on their era. Among these sites, the closest to Penarroya Pueblo Nuevo corresponds to what appears to be a Chalcolithic settlement located on the southwestern slope of the Peñón de Penarroya, where the first phases of excavation have recently begun. In the so-called Abrigo del Carmelo on the Peñón of Penarroya Pueblo Nuevo, in a cave on the northeast side, 6 groups of paintings were discovered in 1965. These paintings have not been thoroughly studied, nor has any excavation been conducted there, but from the few analyses carried out, it is believed they may date back to early Bronze Age, Neolithic, due to the naturalistic tradition visible in some of the figures. Dolmens have been found in various areas of the Guadiaro, confirming the existence of this Chalcolithic settlement, which is associated with mining activity in the valley due to the presence of numerous metal-bearing veins, mainly of copper and lead. As evidence of this, many polished stone tools such as hammers, mallets, and grinding stones have been found, used to extract and crush ore from these veins. In the municipality of Belmez, at Pinaladrones, there are several Neolithic and Chalcolithic examples that have been the subject of various excavations. Another site in La Granjuela has yielded a rich and diverse set of artifacts representing most of the industrial activities characteristic of the local late Chalcolithic and Bell Beaker cultures. The mineral wealth of the basin also saw significant development during the Roman era. As it passed through the Guadiaro region, the road connecting Mérida, Emerito Augusta, with Córdoba, Bietica, facilitated a major flow of goods and people throughout this territory. One key urban center along this route was Malaria, whose remains lie on the banks of the San Pedro Reservoir and are now undergoing early stages of excavation by the University of Córdoba. Among the numerous findings, there is evidence demonstrating a direct link between settlements and mining metallurgical activity during this historical period. Of the 122 Roman-era sites identified in the province of Córdoba, 9 are located in the upper Guadiaro Valley, where it has been proven that they primarily extracted argentiferous lead, just as would happen later during the industrialization and development of Penarroya Pueblo Nuevo. The minerals extracted from these regional sites included argentiferous galena at Mina Cuenca and both argentiferous galena and chalcopyrite at Dona Rama, Almaden's del Guadiaro, La Loba, and at La Anticina and El Rubio, Picancillo. Metallurgy as an industrial and urban development of Penarroya Pueblo Nuevo. Although the mineral wealth of the basin was known since prehistoric times and throughout the Roman era, it was not until the second half of the 19th century, with the arrival of foreign capital, that large-scale exploitation began. In 1860, the French company parent Shaken purchased the Terrible Mine, located near the town of Belmez. This site would become the origin of what would later be the great industrial complex of the province of Córdoba. The characteristics of this location and the richness of the basin in coal and lead set it apart from the rest of the national territory. The coal itself served as fuel for the railway, which became the main driver of the subsequent industrial development. Additionally, this mineral fuel supplied energy to the thermal power plant in the area, providing electricity to all the subsidiary factories. Another key factor in its greater development compared to similar operations in Spain. Thus, coal, as a fuel for transport and energy source for associated industries, was the main driving force behind the remarkable industrial growth of this region. Furthermore, the business strategy of the Penarroya Mining and Metallurgical Company, founded in 1881, focused on the reuse of byproducts generated by the lead smelting plant established on the Terrible Mine site. This strategy provided the final push for the development and consolidation of the Penarroya Pueblo Nuevo industrial complex. Its director, Charles Ledoux, introduced innovative practices from France, such as the reuse of sulfurous fumes from lead smelting. Using the lead chamber process, the plant produced sulfuric and nitric acid, giving rise to a complementary chemical industry, including a sulfuric acid plant and a superphosphate plant within the industrial complex. Due to the high demand for these products, mainly for agricultural fertilizers and explosives, pyrite from Huelva was also imported, and the roasting process yielded copper sulfate. In addition to superphosphates and copper sulfate, fertilizers were produced in such demand that the company built a large textile factory to manufacture jute sacks for packaging, followed by a paper factory for the same purpose. Beyond these industries, the existing deposits in the region and imported or from the mines of Berlanga and Ciudad Real, also owned by the company, allowed for smaller scale extraction of zinc, copper, and silver. As a result, a zinc plant, a copper plant, and a silver extraction facility were also constructed within the industrial complex. Coke was obtained from coal, which was highly sought after, leading to the installation of large ovens. Coal tar, derived from coal distillation, was used to produce briquettes and ovoids, prompting the company to build another factory to take advantage of this byproduct. To supply the refractory material used in both the construction and maintenance of all the industrial complex's factories, a refractory products factory was built. With the company owning a mining railway, large workshops were also built near the station to service the two railway companies operating in the area. In these facilities, besides maintenance and repair of locomotives, tools and replacement parts were manufactured. Consequently, an iron foundry was erected nearby. To support all these industries derived from lead and coal extraction, the company created a thermal power plant that supplied electricity to the factories of the Penarroya industrial complex. This power also reached the electromechanical industry of the provincial capital and provided energy to the newly formed settlement and surrounding towns in the region. All these constructions, which were gradually built around the lead smelting plant and formed the industrial complex, have left a heritage legacy in Penarroya Pueblo Nuevo. This legacy is not only important for understanding the history of a great era of splendor, but also for its architectural value. It features unique characteristics as it introduced construction techniques and technological advances imported from France, then pioneers in Europe, which, when combined with local systems, give this architecture a special and distinctive meaning. Architecture of the industrial complex. The buildings that make up the industrial heritage of Penarroya Pueblo Nuevo are characterized by their design aimed at achieving large open spaces. This pursuit led to the development of an architectural typology distinctive to this location. Based on research for its inclusion in the Andalusian Historical Heritage Catalog, also described in the book El Circo Industrial de Penarroya Pueblo Nuevo, Córdoba. Piedra a Piedra, 2005. 57 building remains have been identified within the site. All are concentrated around the lead smelting plant, forming a well-defined space at the southwestern edge of the town. The architecture of these constructions initially followed a developing form and later evolved into large longitudinal buildings with thick load-bearing walls and gabled roofs, supported by Belgian-style metal trusses and flat ceramic tile coverings. The wall types vary: stone masonry in the oldest buildings, brickwork during the intermediate consolidation stages, and a locally distinctive mix of lime and coal dust, known for its durability and considered an early method of recycling coal waste in construction. This technique has been studied and found in various building types in the town, including industrial structures. The lead smelting plant, located at the center of the complex, is the best example of this architecture. This historicist-style building is linked to contemporary French constructions seeking large open spaces, which peaked during the World Expositions. The architectural similarity is due to the aim of creating large, unobstructed interiors that could be easily adapted for functional purposes. This building, constructed during a time when architecture was closely tied to industrialization, with technological solutions and functionalism as key themes, blends inspiration from various historical styles in its facades. It is a clear example of the architectural typology of the first industrial revolution, where traditional materials like brick were combined with new ones like cast iron, resulting in a type of architecture more detached from the ground, with a limited lifespan and designed to undergo transformations. Another notable example is the refractory products factory. Here, the building's linear form, due to the limitations of its roofing system, is especially evident. The 100-meter-long walls are made of lime and coal dust, with exposed brick reinforcements defining the facades. Later, the refractory products warehouse was added, one of the earliest reinforced concrete constructions in Spain, experimental in nature and exhibiting some reinforcement and mix inconsistencies. The sulfuric acid plant is another significant example of Penarroya Pueblo-Nuevo's industrial architecture. The tallest building in the area, it featured the same construction system: load-bearing walls of exposed brickwork, Belgian-style metal trusses, and flat ceramic tile roofing. This distinctive architectural typology is found throughout the industrial complex, in major industrial buildings and smaller auxiliary structures like dining halls, offices, locker rooms, and warehouses, using wooden trusses for shorter spans. The silver extraction building illustrates the beginning of the typological evolution within the industrial complex. Although its original purpose is unknown, the stone masonry walls suggest it predates or is contemporary with the first smelting facility. Analysis of its facades reveals an initial central building later expanded with lower annexes. Connecting walls were removed to insert intermediate metal columns, creating a continuous interior space, demonstrating the adaptive reuse and evolution of buildings based on functional needs. In the final phase of construction in the industrial complex, the architectural style moved away from load-bearing walls and enclosures, relying instead on fully metallic portico structures. Examples include the iron foundry and the Norden warehouse. The central warehouse showcases a unique structural design where the addition of intermediate metal supports enabled a hybrid solution, combining a longitudinal gabled layout to create a space exceeding 14,000 square meters. Similarly, in the pursuit of design freedom beyond load-bearing walls, in line with early French concrete constructions, several buildings in the industrial complex experimented with this new structural system. Examples include the refractory products warehouse, the copper sulfate warehouse, and the central power plant's boiler room. Virtual tour of the industrial complex of Penarroya Pueblo Nuevo, Córdoba. This project emerged as a tool for transferring the results of research carried out as part of the author's doctoral thesis on the former industrial complex of Penarroya Pueblo Nuevo, which was declared a site of cultural interest in 2018. It aims to disseminate and raise awareness about this heritage. Due to various factors, this site is at high risk of disappearing because of the state of ruin of its buildings, which possess significant historical and architectural value. Additionally, the extensive area requiring intervention poses a challenge given the scale of the municipality. Therefore, the project aims to document this heritage in all possible ways, visually, virtually, and through architectural plans, before its complete disappearance. It also seeks to create a digital tool that enables visualization of the conclusions drawn from the ongoing study. Promoted by the Cultural and Heritage Association Desde la Cima, the project received funding in 2021 from the Alto Guadiaro Rural Development Group through the European Union's LEADER program in its first phase. Part of the work was carried out within the framework of the UNESCO Chair on Built Urban Heritage CRAR in the Digital Era, based at the University of Seville, through a predoctoral stay at the ESMLab laboratory of the School of Architecture at the University of Granada. The first phase also involved collaboration with Fundación Progresa, Fundación Ricardo Pérez Vizcaíno, and the City Council of Penarroya Pueblo Nuevo. As an initial result, a virtual tour was created as an immersive experience using VR headsets. It recreates a visit in both the current and original states of the site, reproducing the 24 most significant buildings, many of which no longer exist, and includes detailed explanations of each area through audio and video based on the conducted research. The virtual visit starts from the only accessible area within the industrial complex according to current regulations, the Santa Rosa Mine viewpoint, created during the first phase of the historical center for mining in Penarroya Pueblo Nuevo. The Department of Tourism sponsored a second phase, in which explanatory videos of the buildings and audio translations were produced. This phase completed the descriptions and introduced new experiences through narrated videos, making the content accessible to people with hearing impairments. Since 2021, the Cultural and Heritage Association Desde la Cima, in collaboration with the Penarroya Pueblo Nuevo City Council, has been conducting on-site group visits to the tour from the top of the viewpoint. Additionally, the website has been receiving visits and program engagement from various countries, demonstrating its international reach. The site offers general information, the option to take the tour freely, and the immersive experience from anywhere with a VR headset. Currently, a third phase is underway, incorporating auxiliary buildings and new visualization techniques through photogrammetry and augmented reality. All the work carried out is contributing to a proposal for the intervention and recovery of the area and the studied buildings. Thus, the reconversion of the industrial complex is proposed as a sustainable development strategy for the locality, based on a study that allows for the urban development of the area in line with its protected status. Among other factors, cultural tourism promotion will be considered as an efficient way to utilize existing resources, moving toward a model of sustainable tourism.
Well, I think everybody agrees that that was a very impressive piece of work. It happens that my hometown is not far from this site, and I have been there several times. And I can tell you how challenging researching that site is, because the site is huge and the level of destruction is already very advanced. So what Maria Isabel has just offered here to us, you can believe me, is a very impressive result. Both from the point of view of the research and advancing knowledge, but also from the way in which these advances in knowledge have been presented with that amount of 3D and drone flights that, well, certainly make video presentation the best option in this case. So we can really see how much, how good is this research and how powerful these new means of presentation are. So very good job, Maria Isabel. Congratulations. Enhorabuena. So now we have 20 minutes for the questions and answers. Everybody is welcome to open microphones and mics and cameras and make any questions you want. Also, you can use the chat if you prefer to text rather than to talk. I will break the ice so we can start the discussion. I have questions for all of you, actually. I'm going to make all my questions first, and later you can answer following the order of the presentations, okay? So first for Chen Yuan Li, I would like to know when was coal first used or discovered in China for metallurgical uses or for any other use. And even though this has not been the topic of your presentation, I don't know if you know when coke instead of coal started to be used in metallurgy in China. Well, everybody knows that coke was first used by Abraham Darby I in the UK in 1709, or at least he was the first one to patent this way of producing iron using coke instead of coal or charcoal. So if you know, I would like to know when this happened in China, but mostly when coal was first used. And also I would like to know if if there is any relationship, perhaps there is not, between all those pieces of pottery and between the pottery and metallurgical industries that you have shown in your presentation. For example, I wonder whether those ceramic typologies, the same shapes and designs can be found also in metal. And if that is the case, what are the reasons that may explain the selection of pottery or the selection of bronze or any other alloy or metal to produce a given artifact? For Rhys Morgan, I would like to know more or less what percentage of the excavations developed by the Black Mountains archaeology are related to industrial sites, because from your presentation, I get that you are excavating plenty of industrial sites. And also, I wonder whether there are differences in terms of methodology, the tools used, or the management of the findings between the excavations of these industrial sites and older, let's say, more traditional archaeological sites, like from Roman times, medieval times, or older archaeological sites. And finally, for Maria Isabel Paller Ibáñez, I feel sad to see that most of this fantastic industrial site is going to disappear. So I wonder whether there are any further plans for the reutilization and the reactivation of the industrial buildings of the PERCO, the Peñarroya industrial sites. I understand, as you have explained, that for a small town such as Peñarroya Pueblo Nuevo, the recovery of this space is extremely challenging from an economic point of view, but we have also the problem that the soil is contaminated with heavy metals. And so to what extent people can come back to this industrial archaeological site without any significant risk for them, for their health. So in short, I would like to know your opinion about the future of this site. So those are my questions. So Chen Yuan, please, would you mind to start?
Okay. For your question about the core, I think as I remembered this, we have found some cores in the tombs, but it's not used for the smeltings. I think it's also in some sites in Xinjiang. It's around, I think it's around 3,000 BP. Is in Xinjiang, but if you said it's actually used for the smelting, I think it should be from the Han Dynasty, because we have some the smelting slags which contain the very high values of the sulfur, because we think the ancient artisans they already knows the sulfur in steels and in iron can just lower the the quality of the artifact. So they didn't use it until they used the crucible to deal with the smelting iron. So I think if the evidence now we have is from I think the Western Han Dynasty, but the people mainly used still use charcoal for the smelting, and for the coke, I believe we still don't find very solid evidence to use the cokes, but I think if you check the literature records, we can find out the people or the artisans of the South Song Dynasty, they already know how to make the coke, and I think you can find the evidence in the Guangdong province size. I can't remember the name, but it's in the Guangdong province. In the record they have already have the coke inside. And I must apologize about the presentations. I didn't explain very well for the topology part, because in our research that we don't have a very clearly context about the Qing dynasty, and especially for the Xiongnu, for Xiongnu part of the archaeology context. So we can only use the most I think the most sophisticated research on the potteries to give a background of our research. That's why we use those pottery typology research to try to understand how the the social the society of high density and also the Shunnu density. This was also why we use the AI assistance that make our research can combine our archaeometallurgy data with the pottery typology result together. In the formal research, we cannot directly to make the two kind of data together. Now we can use this kind of new technology to make the cross modeling analysis for the also the analyze, especially for the cluster analysis for the further for the research. That's why we mention about this.
Good. That's very clever. Thanks, Chen Yuan. Brice, please.
So your first question was about how much of the site have we excavated and recorded? I guess. So we've actually uncovered significant portions of the Howard Morva site. Certainly haven't excavated all of it, far from all of it, but with regards to the Morva site to the north, we undertook a very big excavation, and we found a variety of different remains associated with a variety of different industrial processes, like casting and rolling mainly, but we also uncovered like laboratory buildings, we uncovered a bathhouse, we uncovered flues, furnaces. That it's just so much to go into, and all of this I think needs publishing. With the Harvard site, we haven't uncovered so much. Most of what we have seen is when during the regeneration project they had to dig drainage channels across the site, and so we found a lot of archaeology in these drainage channels, but as you can imagine, they're very narrow, and they only offer a kind of really partial glimpse of the archaeology. So we're still kind of interpreting those smaller excavations. And then your second question was, to do with the possible differences between industrial remains. Okay, and yeah. So industrial archaeology is recorded in exactly the same way as any other archaeology, whether it be prehistoric, Roman, medieval, whatever. But the main difference I've noticed with excavating industrial sites is we'll uncover something, and I'll have no idea what it is. Like I can see like there's bricks, there's concrete, it's some sort of structure. So, but I'll record it, and we use a lot of photogrammetry, so we'll record it in 3D and stuff like that. And I find that a lot of the interpretation is done in the office after the excavation, sort of post-excavation stage. This is kind of different with say a Roman site, because on a Roman site, for example, or a prehistoric site, you have a collection of, say, post holes, and you can see these post holes form a structure, and with analyzing the kinds of finds associated with these structures, you could say this is, for example, a house, because there's a lot of domestic pottery. You can't really, well, I can't really do that with industrial archaeology in the field. It's so complicated that we need to take everything back to the office, purchase maps, purchase photographs, and then we can see how we can kind of piece all of these different elements together. But I personally, I think it's a far more kind of rewarding experience with industrial archaeology, because so much stuff to kind of figure out, if that makes sense.
Good. I was particularly interested in making this question because here on the East, people often distinguish between traditional archaeology and industrial archaeology as if they were totally different disciplines. So one of the ideas that I like to discuss in this kind of workshop is that, well, industrial archaeology, of course, there are many different ways of understanding industrial archaeology, But one of them is that industrial archaeology is archaeology, and it doesn't matter whether the site that you are studying is 2,000 years old or just 200. In the end, is the same methodology, the same theory, even though, as you have explained pretty well, there are some little differences that are demanded by the nature of the sites that we are excavating. So thank you very much, Rhys. And we have an answer from Maria Isabel on the chat facility that I am going to read. We are currently still trying to obtain funding for the Mining Historical Center project in the old Santa Rosa mine within the Cerco Industrial, the industrial site, which is the only land on which it is possible to act together with the central warehouse building and on which the corresponding decontamination work was already carried out in 2005. Also in 2024, I drafted 2 projects for the Peñarroya Pueblo Nuevo Town Council to apply for European funds. One is the adaptation of the old central warehouse recovered in 2010 to provide it with use as a social and cultural innovation center. The other one is the creation of social urban gardens and center of digital transformation and sustainable agriculture that repair the extensive area degraded in this plot by mining and industrial activity. Both were accepted, but were not funded. So, well, good luck with the funding. I hope that money comes because the projects are really significant. And the answer continues. The study of the characterization of the land and the corresponding decontamination projects are indispensable requirements for the environment in order to develop this area, taking into account the cost and the fact that there is not even a commitment to invest in the 2 areas that can be put to a new use. It is likely to be quite difficult to recover them immediately, which makes me very sad, but at the same time, I'm happy that your 3D work and your documentation work is so extensive. So at least the site can survive virtually. And finally, she adds, the reality is that the situation of degradation of the buildings is quite serious, and taking into account the previous steps necessary to rehabilitate them due to the previous decontamination and the development of an urban plan that organizes the space according to its new protection and projects new uses for the population, the problem increases quite a lot. At the same time, I think that the right steps are not being taken by the administration for its recovery, as the first step should be to carry out an urban plan, something that is not yet in place, that is carried out by professionals specialized in the rehabilitation of this type of heritage, and that the study of the area from all its aspects is carried out without this action. The other possible actions that are being considered will mean further delays and will have further repercussions on the deterioration of the buildings. So as everybody can see, the situation is pretty hard for this industrial archaeological site. But, well, as I say, it is precisely for this that I find the work developed by Payer so important, because at least the information is not going to be lost. We have also a comment by Rui Carvalho. He said, good morning, everyone. Thank you to the Association for Industrial Archaeology and the authors for the excellent presentations. He would like to ask to Rhys Morgan regarding the research carried out and the documentation gathered on the copper smelting sites, Hafor and Mofa in Swansea Valley and also in Swansea Harbour, if there are any records of the origin and the companies supplying the copper ore, that is the mining companies between the mid-19th century and the mid-20th century, and if he knows how and where they can be found.
So yes, there are many documents. we've read only a small part of them. They're available in various archives. So there's an archive in Swansea known as the West Glamorgan Archives. There's tons and tons and tons of material there. But these kind of documents are also spread out across other archives, mainly in Wales, but also across the border in England. So yeah, I didn't really have time during my talk to kind of go into names of companies and things like that. But yes, we do have a lot of information on who owned and operated the copper works at different times. Also there's photographs that I used. They were also from archives as well, and the plans that I used as well. So yes, there is a lot of material. Unfortunately, when it comes to the earliest activity in Swansea, like the sort of 18th century, as you can probably appreciate, the documentary evidence becomes thinner. But certainly the late 19th century and then 20th century, yes, there is a lot of documentary evidence.
Okay, thank you, Rhys. Any other, and thank you also to Mr. Carvalho for his question. Any other questions or comments?
Can I ask a question?
Of course.
Okay, I have a question for Chen Yuan. So that you mentioned the early use of coal in smelting and producing pig iron. I was wondering if there were measures in place to remove the impurities like phosphorus and sulfur from the pig iron that must have been absorbed from the coal, because this was a huge issue in Britain during the Industrial Revolution, and I think the overcoming of these issues kind of really kick-started the Industrial Revolution in Britain. So I was very interested in that, considering how early the site is.
You mean
yes.
the phosphorus, right? In the cast iron, right? The sulfur, yeah, or the phosphor.
Well, phosphorus, like anything that was absorbed from the coal into the pig iron, which I guess would make it kind of brittle and stuff like that.
I think the sulfur, we have some slag, the smelting slags in the I think in the Liao Dynasty site. It's also the same period in Song, and we found that they got some we call it's the Baiyun Shi. It's contained some how to say the calcium minerals, and we know they put inside the furnace, and this site is just near Beijing. It's also not to the in the Yan Mountains, and in that period they already know they need to control the contents of the slag to purify the metals. But I think the phosphor, we will continually find the kind of high content in the pig irons in our artifact, both in the Han Dynasty and later in Tang Dynasty. And I don't think for phosphorus the artisans have the ability to purify it. And but when we use the decarbonized processing, like stir fry process, it's kind of different from the paddling steels, just like you do in the modern industrial, as we forging the iron, forging the iron and make the inclusion out. In our literature literature record. We didn't know whether it's the truth, but they said they just stirred the liquid, the iron, and make the decarbonized achieve, and then they will the reflection will automatically going, and finally they got the iron. I think it's not the cast iron, as should be the more like the bloomer iron. It's pure iron without with a very low carbonized. So I think in Liao Dynasty, or maybe in the Han Dynasty, the artisans already know how to purify some of the like sulfurs in the steel, but for the phosphorus, they never do it. But use the stir fry processing, maybe they can lower the level of the phosphorus. Thank you.
Thank you very much, Yuan. Very technical answer. We have time for a last question that is for Maria Isabel Payer Ibáñez. You can use the chat facility if you prefer. Dondon One, well, thanks all the speakers. And she says that she's learning about the materials of industrial architecture. And in the presentation, the video presentation by Payer, she saw some buildings with red pillars and red windows, maybe made by red bricks or stone, while in other parts of the building, this was the fabric was stone. So she would like to know whether this is a typical Western architecture.
¿Contesto en español y traduces tú?
Okay, she will answer in Spanish. I will do the translation.
Bueno, pues comienza la arquitectura industrial, por ejemplo, en nuestra zona, comienza con la tipología tradicional que hay allí de muros de mampostería, que era el sistema de sujeción, de sustentación vertical tradicional, y va evolucionando conforme va evolucionando la técnica constructiva. Evoluciona a partir de la última mitad del siglo XIX a muros de carga de ladrillo, para finalmente a partir de 1920 aproximadamente totalmente se desvincula ya del muro de carga y ya trabajamos con los pórticos totalmente metálicos, que es el sistema al final que se utiliza para la arquitectura industrial, que es la que facilita más las transformaciones de los edificios en función de las necesidades. No sé si eso contesta la pregunta.
Sí, muy bien. Okay, so Maria Isabel has just explained that, well, first it's difficult to talk about traditional Western architecture in general because, well, there is not only one traditional Western architecture. But in the case of the region where the industrial side of Peñarroya Pueblo Nuevo is located, there indeed stone walls with load-bearing functions were indeed the traditional way of building. So this traditional way of building was incorporated into the industrial side, but later, soon after, with the beginning of industrialization, these stone walls were replaced by brick walls. But still, from the technical point of view, architectonic point of view, they were the same, load-bearing walls. So these walls, made of stone or made of bricks, were supporting the whole structure of the building. The biggest revolution will come from 1920 onwards, when the building walls disappear and the buildings are supported by metallic frames, which is a much more typical way of building from the industrial architecture, at least from the late 19th and early 20th centuries. I agree very much with this answer because it happens that we are working also in my research group with French architecture, but in China, and we are also seeing this transition from the load-bearing walls made of bricks normally into more modern structures with metallic frames. Muchas gracias, María Isabel. Muy buena respuesta. So I think we are already above time. It's time for breakfast, lunch, or dinner, depending where you are. So thank you very much to all the speakers for their amazing presentations. Thanks, Bill, for taking care of the technical aspects and making this work, particularly today. That was more challenging since we have a video presentation. And of course, thanks to all the attendees that are the real reason that we are doing this. I hope to see you again on November when I can already advance. We are going to be discussing the railways. So have a lovely weekend and thank you very much to all of you.
Bye.
Gracias.
Thank you.
Gracias.
Bye.
Yeah, bye-bye.
Thank you.